do the actual work. This is the case for both the storage and the compute parts of the platform. The storage layer is called HDFS, the Hadoop Distributed File System, and it runs on the cluster as two different services. The master server runs the name node service, which stores the file system directory and is the entry point for clients to access data. The workers run the data node service, which actually stores and retrieves data. In HDFS, data is replicated across many data nodes. Large files are split into blocks, and the blocks are replicated across several nodes. By default, the block size is 128 megabytes, and the replication factor is 3, so if you store a 1 gigabyte file in Hadoop, it will be split into 8 blocks, and each of those 8 blocks will be copied 3 times across the cluster. There are 2 reasons why HDFS does this. The first is availability. By having many replicas of data, the cluster can survive outages. If one data node has a disk failure or loses connectivity, there are 2 other nodes with the same data that can be used instead. And the second reason is performance. We'll see later in this module that the compute part of Hadoop breaks work up into many tasks and distributes the tasks across the workers in the cluster. Each task will have one file block or one whole file as its input, and by replicating the data across many nodes, Hadoop increases the chances that it can schedule a task on a node which has the data stored on its local disk, which is much faster to access than reading it across the network from a different node. There are 2 key things to know about HDFS. Firstly, the block size and the replication factor are configurable, and that can greatly affect performance. If you routinely work with very large files and have plenty of storage, you can increase both values and have larger blocks on more data nodes, which can speed up your job execution. Secondly, the name node keeps the whole file system directory in memory for performance. Every file block on every data node has an entry in the directory, and even though each entry only takes up a few bytes, there is a physical limit to how many file blocks the name node can hold in memory. Typically, Hadoop is better with a smaller number of larger files. We're still talking about millions of files, but maybe not billions. That impacts your design for storing data. It's better to combine an hour's worth of data in one file rather than store it as thousands of small files. That's enough theory for the moment. Next, we'll have a look at what it's like to work with HDFS from the command line.